done our homework on guess what?
Not yet. It's super hard. I tried starting it, but it's super hard. Have you?
Not yet. Let's try answering then.
Oh my God, Joseph, I can't solve this. It's too confusing.
Makakatulog game.
Oh! Where am I?
Stubborn ito eh. Tigas ulo mo eh.
Pero wala kang magagawa, stubborn nga eh.
Matigas
Ano pa
yung ulo
inaaway
mo
yung
eh.
mga taong stubborn?
Matigas yung ulo mo eh. Matigas yung ulo mo eh. Matigas yung ulo mo.
Aladdin!
Aladdin!
Who's that?
Hi, Aladdin!
Aladdin? I'm not Aladdin.
You are Aladdin in this world, in this whole new world. I am Baila Baila, the goddess of dreams. I know the answers to your problems in Ysmael. You must obtain the magic lamp, because all the answers are there. But first, you must know the basics about the first moment of areas. Let's say we have an irregular shape with centroid C and area A. A centroid is also referred to as the center of gravity or center of mass, is the arithmetic mean position of all the points on the shape. Now, how do we get the centroid of the irregular shape? That is where the first moment of area comes in. We use the concept of the first moments of area to get the centroid of the irregular shape. I'm going to place the origin on the lower left side of the irregular shape with the y and x axis. Let's get a very tiny portion of the plane and call it dA. This tiny portion is also called the differential or infinitesimal element. It is a very small portion of the plane that, when integrated, can define the whole plane. The differential element is located on the x and y coordinates. There. In order to get the first moment of area, we must integrate yda and xda. So let's call them qx, integration of yda, and qy, integration of xda. Then we will be able to obtain qx and qy. And to get the centroid, which is placed on the x bar and y bar coordinates, you use the formula x bar is equal to qx over the area, and the y bar is qy over the area. We can see here that when the dA is integrated, it's going to be y times the area, which will give you a unit of LQ, L being meters, feet, inches, and so on. So there, we have the first moments of area. There, I hope you keep these in mind. Might I remind you that I will send 3 followers throughout your journey to help you to get to the magic lamp. And before you can get the magic lamp, you must first answer the problem it will give you. That is all. Good luck on your journey.
Okay, thank you so much, Baila Baila. Where's the magic lamp? I can't find the magic lamp. Magic lamp. Tapos magugulat lang ako. Paano magugulat?
Doon ka titingin ah. Sa frame.
Oh, you must be Aladdin. Here's the clue that you're looking for. In a right triangle, here is how you solve the moment of inertia. This is the base, here is the height. To get the moment of inertia at x-axis, I bar x is equal to bh cubed over 36. To get the moment of inertia at y-axis, I bar y is equal to b cubed h over 36. To get the moment of inertia at xy axis, I bar xy is equal to negative b squared h squared over 72. In a isosceles triangle, here is how you solve the moment of inertia. Here is the base, this is the height. To get the moment of inertia at x-axis, I bar x is equal to bh cubed over 36. To get the moment of inertia at y-axis, I bar y is equal to b cubed h over 48. The formula for the moment of inertia at xy axis is I bar xy is equal to 0. In a rectangular form, here is how you solve the moment of inertia. This is the base, here is the height. To get the moment of inertia at x-axis, the formula is I bar x is equal to bh cubed over 12. To get the moment of inertia at y-axis, the formula is I bar y is equal to b cubed h over 12. The formula for the moment of inertia at xy axis is equal to 0.
Triangles, isosceles triangles, right triangles, but I still can't find the magic lamp.
Para makatulong sa problema mo sa moments of inertia ng circle, ito ang kasagutan. Radius I x bar equals to iy equals to 1 over 4 pi r to the 4th. Susunod naman ang semi-circle. I x equals iy 1 over 8 pi r to the 4th. Isa pa ay yung quarter circle. Ix equals iy equals 1 over 16 pi r to the 4th. At ang huli, ay ang ellipse. I bar x 1 over 4 pi a times b cube at I bar y 1 over 4 pi a cube b. So yung a, yun yung pahaba, which is yung length, and yung b is yung height ng ellipse. Yun lang. Sana makatulong to sa iyong mga problema.
Circles, quarter circle, semicircle, ellipse, ellipse nga ba yun?
Magulat. Where's the magic lamp?
Ah!
Oh, you must be the Aladdin that Violet is talking about. Here's the other clue. We have here the half parabola complement. As you can see here, we have the base and the height. We have here the formulas of the moment of inertia about the axis and about the centroidal axis. Ix bar is equal to 37 bh cubed over 2100. Iy bar is equal to b cubed h over 80. Ixy bar is equal to b squared h squared over 100. Now here we have Ix is equal to bh cubed over 21. Iy is equal to b cubed h over 5 and Ixy is equal to b squared h squared over 12. Next is the half parabola. As you can see here, we have the base and the height. Ix bar is equal to 8 bh cubed over 175. Iy bar is equal to 19 b cubed h over 480. Ixy bar is equal to b squared h squared over 60. Ix is equal to 2b h cubed over 7. Iy is equal to 2b cubed h over 15. And Ixy is equal to b squared h squared over 6. We have the circular sector. As you can see, we have here the radius and the angle alpha. X bar is equal to 2r sine alpha over 3 alpha. Ix is equal to r raised to 4th over 8 times the quantity of 2 times alpha minus sine 2 alpha. Iy is equal to r raised to 4 over 8 times the quantity of 2 alpha plus sine 2 alpha. And last we have the Ixy is equal to...
I finally know where the lamp is! Yay! Hindi pala ito. The lamp! Yay! How does this thing work?
Okay. They finally found me. Sabihin mo, sabihin mo, oh, someone finally found me.
Oh, you found me. I had the genie in the lamp. Oh, wait, I'm working out. Wait, stop me.
May 100 people na nila.
Hello. What do you need?
How did you fit in here?
Magic.
So, where's my 3 wishes?
You can have your 3 wishes if you can learn this final problem.
In this figure, we're given this figure for this sample problem 8.2. We need to calculate for 2 things: the moment of inertia at the x-axis and the moment of inertia at the centroidal x-axis, which is Ix and Ix bar. Okay, but to solve for that, we will need to get the individual Ix of the composite figure, which is a semicircle, a circle, and a triangle. So these are the solutions for that. We will need to get the area and the Ix. So to solve for the area of the triangle, the equation is base times height over 2, and we would get a value of 4,500 millimeters squared. Ix bar can be calculated using bh cubed over 36, which is equal to 2.5 times 10 to the 6 millimeter to the 4th. Now substituting those 2 values into the equation of Ix, we would get 22.5 times 10 to the 6 millimeter to the 4th. To get the area of the semicircle, we would need to use the equation pi r squared over 2. The r of the semicircle is 45 millimeters, therefore the value of the area is 3,181 millimeters squared. To solve for the Ix bar, we use the equation 0.1098 r to the 4th, which, if calculated, would result into 0.4503 times 10 to the 6 millimeter to the 4th. Now, to get Ix, we'd substitute the values of Ix bar, area, and centroid, and we would get 45.57 times 10 to the 6 millimeter to the 4th. Lastly, for the circle, the area of the circle is equal to pi r squared equal to pi 20 squared equals 120 at 1257 millimeters squared. to get the Ix bar, we would use pi r to the 4th over 4, which is equal to pi 20 to the 4th over 4. And the value is 0.1257 times 10 to the 6 millimeter to the 4th. To get Ix, we will need to substitute Ix bar times plus the area of the circle and the centroid of the circle, which is 100 millimeters. And the resulting value would be 12.7 times 10 to the 6 millimeter to the 4th. Now, given that we've already solved for the Ix of all the shapes, we would need to use take the summation of all the areas and all the Ix to get the total area of the composite area, which is 6,242 millimeters squared, and the total Ix, which is equal to 55.37 times 10 to the 6 millimeter to the 4th, which is the answer to the first question. The second question asks for us the Ix bar of the composite figure. But since we don't know the centroid of the composite figure, we need to get it using the equation of the centroid, which is y equal to the first moment of the area over the area. And to get the first moment of the composite area, we will need to get the summation of all the areas and all the centroids, which is equal to 86.13 millimeters. Now, given that value, we need to substitute it to the Ix that we got earlier minus the composite area times the new value of the centroid, which is equal to 7.71 times 10 to the 6 millimeter.
Given this problem, you're asked for the h, which is this one. We have a moment of inertia about the u-axis, the moment of inertia about the x-axis, and the area of the figure. We will be using this equation. The moment of inertia about the x-axis is equal to the moment of inertia about the centroidal axis plus the area times the square of the distance of the x-axis to the centroid. Using this, we will be getting the moment of inertia in the centroidal axis. Then, after that, we will be using this answer, which is 5.9 times 10 to the 9th millimeter to the 4th, to get the height, which will be this equation. Using this values, we will be getting a height of 825.95 millimeter.
Sample problem.
Yes! I finally answered the problems!
Okay, you can now wake up from your deep slumber, and after you awake, all the answers will be on your head.
Thank you.